So today's going to be a little bit different. The video today is going to be really just kind of me going through some of the problems that we've gone over the last a few days. Sorry, a little bit bright right now. But I just want to go over some of the problems to make sure that we've got a good grasp of what's going on sections 5.1 through 5.4. You are going to have a quiz next Tuesday over sections 5.1 through 5.4. It's probably Friday today. But in 2 days class-wise from now, you will have a quiz over this material. And then the day prior to the quiz, we're actually going to move on to section 5.5. That won't be on the quiz. But this certainly will be from 5.1 to 5.4. So I wanted to get kind of everybody on the same page, make sure we're good with finding answers to the different things in the video. I'm going to go through the problems. If you just want to kind of pause it at points, I'll do the explanation as I'm going through all the problems. If you just want to pause it, try the problem yourself, and then start it up again, you can certainly do that. But this is just kind of to get you to look at more problems and have more problems done for you, so you can see the examples to kind of help you out in the process. When you're looking at this first question, you're just asked to find the square root of 1.21. Honestly, just use a calculator to do this. That's how you're going to do it in everyday life anyway. So just hit your calculator, square root of 1.21. Make sure you close parentheses around it, and you get 1.1. Pretty straightforward. Just use your calculator. For the next one down there, the fourth root of 81, x to the 28th, y to the 8th. So remember, we got to take essentially that fourth root of everything. So we're going to take the fourth root of 81. Now, instead of writing the variable as the fourth root of 128, I'm going to go ahead and write that as a fraction. So as an exponent. So that's x to the 28 over 4 and y to the 8 over 4. Break down the fourth root of 81 if you want to plug it in your calculator. See if that works. If you want to use the factor tree, whatever way you want to do the 81 at this point, it's always a good thing to try it to see if it works in the calculator. If it doesn't work in the calculator, then do the factor tree. This gets you just get 3 groupings of 4. 28 to the 4th, so 28 divided by 4 is 7, so that's x to the 7th. 8 divided by 4 is 2, so y squared. So there's your solution for the second one. For the next one, it says write the exponential expression to x to the 2/7 in radical form. So it's an exponential form right now. Now we need to put it in radical form. Now notice what your base is. Your base is the x value. The 2 has nothing to do with your base. So the 2, we're just going to kind of change colors here. We're just going to kind of, the 2 is going to kind of go off by itself. It's not risen to a power, so it's just kind of by itself. The denominator is our index, and then we're going to square the x value. Okay, and there are, as I said, we've said in the past, there's a different way you can write this. Kind of looking at, my eyes are up kind of at the quiz that's for this week, because this is really just a quiz review, and it looks like they do write it in the form that I have it right here, and we're good to go with that. Okay. The next one, 8 to the 1/3. Again, it just wants us to write it as, or simplify this, I guess. So we're going to simplify it. So 8 to the 1/3. So if we think about that, that's the cubed root of 8. It's 4 times 2, 2 times 2. So the cubed root of 8 is just 2. You're done. The next one, 7 to the 1/2 times 7 to the 1/2. So when you multiply two bases, the same bases together, you add the exponents. So our base is going to be 7, and then kind of on the side, 1/2 plus 1/2. 1/2 plus 1/2 is 1. Don't need to put a 1 there. So you just get 7. All right, the last one down here, I'm going to go ahead and move it up just a little bit. So we've got 8a to the negative third, all of that risen to the negative 2/3 power. Okay, so that means we need to distribute that negative 2/3 into each of them. So that gives me 8 to the negative 2/3. And then a, now we're going power to power. So we've got to go negative 3 times negative 2/3, which would be 6/3, which would just be 2. So that's a squared. Now the 8 to the negative 2/3, I would go ahead and just punch that in a calculator. It's probably what you're going to do anyway. So on a calculator, clear, I'm going to hit 8, and then caret, and then negative, oops, and then, so 8, and then inside parentheses, negative 2 divided by 3. And that gives you 0.25. So you could say it's 1/4 a squared, which is equal to a squared over 4. And if you think about, does that make sense? It's negative, so remember, if it's negative, that means we're dropping it down to the denominator. So we would have 1 over 8 to the 2/3. The cubed root of 8 is 2. 2 squared is 4. So, you know, mathematically it makes sense. Well, we did it on the calculator, so of course it makes sense. So there's page 2. Page 3. Now we're going to ask to solve an equation with this one. And find the solution to 4x cubed equals 108. So step 1, we're going to isolate the x value. So we're going to divide by 4. 108 divided by 4 is 27. So we get x cubed equals 27. To get rid of cubing something, you take the cubed root. So the cubed root of x cubed is equal to the cubed root of 27. The cubed root of 27 is just 3. Next one, a little bit different, a little bit of a story problem. So we'll do a little bit of solving, but I think we'll be okay. It says the formula for the volume of a cone is V is equal to 1/3 pi r squared h. It's asking us to find the radius to the nearest hundredth of a cone that has a height of 3 inches and a volume of 15. Well, V is our volume, and they tell us that that's 15 inches cubed. So we've got 15 is going to equal 1/3 times pi times my radius squared times my height, which they said was 3. Okay, so now we simplify. 1/3 of 3 is just 1. So we're left with 15 equals pi r squared. Since we have to round to the nearest hundredth, we're going to go ahead and divide both sides by pi. I'm going to go this direction with it. So 15 divided by pi, that gives me 4.775 equals r squared. And we're going to take the square root of that. So the square root of that is 2 point, there's my tens, there's my hundredths. That's my r value, so that's the radius of our cone. Oops. The next one, we're going to change the color here to red so we can distinguish it, or green. Let's go green. Okay, so we've done one like this before. I'm just going to try to do it again here. This one's a little different. So we're going to go the cubed root of 108. And then we're going to go a to the 10/3 and b to the 12/3. So we have to break down 108. 108 divided by 4 is 27. So you get 4 and 27. That's 2, 2, 27 is 3 times 3 times 3. So we're looking for cubic, so that's 3 comes out times the cubed root of 2. That's what 108 is. I think. Oh, 2 times 2 is 4. That should be a 4. 2 times 2. Got to multiply those 2's together. Sorry about that. 2 times 2 is 4. Now we look at the a values. So we've got a to the 10 thirds. So we want to be able to break that down a little bit and figure out what goes outside and what goes inside. And we talked about this a little bit on Tuesday with this, but I want to kind of speak to this again. When we're trying to figure out what goes outside and what goes inside, there's a shortcut method to do this. And first hour, I'm not sure we broke it down really. Third hour, I know we did. But when you break this down, what you're looking at is you're looking at your denominator and saying, okay, how many times does my denominator go into my numerator? And that's how many of that variable are going to come outside of the radical symbol. And then how many are left are going to stay inside of the radical symbol. So if we've got a to the 10 thirds, 3 goes into 10 3 times. So that means a to the third is going to come outside of the radical symbol. And then we're going to have the cubed root of a. Because we've got 1 left. 3 times 3 is 9. We have to have 10, so that's why we have 1 left. So a to the 10 thirds is the same thing as a cubed times the cubed root of a. So then we look at the b to the 12 thirds. 12 divided by 3 is 4. So that's just going to be b to the 4th with nothing left over. So now when we write the solution to this, we write what's outside and we just combine it. So we've got a 3 on the outside. We've got an a cubed on the outside. We've got a b to the 4th on the outside. And then you put what's underneath, which in this case is 4a. And that's our solution for this question. And we're done. When you multiply, if it's underneath the radical and it has the same index, you just multiply them together and then simplify. So we've got radical 12 times radical 6. 12 times 6 is 72. And this is radical 72. So we've got to break down radical 72. So that's 36 times 2. 36 is 6 times 6. So that at this point, I don't have to go 2, 3, 2, 3. It just doesn't make sense to do it anymore because I've got a pair. So 2 radical, or 6 radical 2 is your solution for that one. With the next one, we got the cubed root of 2x to the 5th times the cubed root of 7x to the 8th. They're both, the indexes are the same, so we can just multiply together. So that gives us the cubed root. 2 times 7 is 14. X to the 5th times x to the 8th. You add them together, and that gives you x to the 13th. Now we need to simplify this. So we've got the cubed root of 14, which we can't really break that down. And then we've got x to the 13 thirds. Okay, so we can break that x to the 13 thirds down. 3 goes into 13 4 times. 3 times 4 is 12. And that leaves us with 1 left. Oops, that should be an x instead of an a. And then we've got 1 left, so 1 has to stay underneath. So our solution to this then, we've got these two pieces of it. X to the 4th is on the outside times the cubed root of 14x. And that's your solution. I don't like how I wrote that x to the fourth. I don't like how I write in general, but yeah, sometimes it's worse than others. Okay. Simplify the next one. Since they're both underneath radicals, I'm not going to do the cubed root of 262. I'm not going to multiply this by root of 2. Since 162 is divisible by 2, I'm just going to do that. Reduce it, so to say. So this becomes the cubed root of 162 divided by 2 is 81. So this becomes the cubed root of 81. And now we just need to break down the cubed root of 81, which we've done, I think. It's 9 times 9, 3 times 3, 3 times 3. We're looking for cubed roots. So we've got one set, and then we've got one underneath. So that's 3 times the cubed root of 3. A couple more pages. The next one, we're going to add and subtract. When you add and subtract, in order to add and subtract, they have to have the same index and the same radicand. So they have to be the same root, and what's underneath the radical symbol has to be exactly the same. We don't care what's on the outside, just what's in the inside. So that means we need to break all of these down into their simplest form. So 147 147 divided by, gotta find something that goes into it. What goes into it? 27? No. 147 and 9. Nope. 147 and 16. Nope. I'm just picking perfect squares. 147 and 81. Nope. 147 and 49. There it is. So it's 49 times 3. I just started picking perfect squares. 49 times 3, 49 is 7 and 7. So this is going to be 7 radical 3 plus, and we go to the 75. 75 is 25 and 3. Nice. Let's try that again. It's 25 and 3. So 5 radical 3. And then minus radical 3. So we've got 7 plus 5 is 12. 12 minus 1 is 11. So that's 11 radical 3. All right, the next one. We got the square root of 3x squared y to the 12th divided by the square root of 7x to the 6th y to the 7th. First thing I'm going to do with this one, we could do it. First thing I'm probably going to do with this one is I'm going to write it as a single square root and reduce. So we've got 3x to the 12th y to the 12th over 7x to the 6th y to the 7th. Those are it's the same thing. Now we can reduce our x's and we can reduce our y's. So number-wise, we still got the 3 and the 7. Variable-wise, 12 is bigger than 6. So 12 minus 6 is 6. So that means I'm going to have x to the 6th in the numerator. And 12 is bigger than 7 for the y value, so 12 minus 7 is 5. So that's y to the 5th in the numerators. So now we can rewrite this as the square root of 3 over the square root of 7, or we could rewrite, guess, the square root of 3 x to the 6th y to the 5th over the square root of 7. We don't like square roots of 7 in the denominator. We don't like square roots in the denominator, so how do we get rid of square roots in the denominator? we multiply by this by the square root of 7 over the square root of 7. So that gives us, let me change colors here, that gives us the square root of 21, x to the 6th, y to the 5th, over square root of 7 times the square root of 7 is the square root of 49, which is just 7. Now we got to look at simplifying it a little bit more and see if we can simplify what's underneath. So the square root of 21 we can't touch. That has to stay underneath. If we look at the x values and we kind of do a side thing over here, this would be x to the 6 halves, which means on the outside we would have x to the 3rd. If we look at the y, it would be y to the 5 halves. 2 goes into 5 twice, so that means we have 2 of them on the outside and 1 on the inside. And then all of this is over 7. And there's your solution. A lot of work with that one, and there's different ways to do that one. I just think that's probably the easiest way to do it. Now I'm fighting the shadow. That's okay. All right. Next one's multiplication. -6 plus radical 6 squared. So remember, this is -6 plus radical 6 times -6 plus radical 6. FOIL, -6 times -6 is 36. We've got -6 radical 6 and -6 radical 6, so -12 radical 6. Radical 6 plus, radical 6 times radical 6 is radical 36, but radical 36 is just 6, so plus 6 more. When we add these together then, 36 plus 6 is 42, minus 12 radical 6. And there's your solution. FOIL. First, inside, outside, last. Five more questions. Again, we're going to FOIL. Radical 10 times radical 10 is radical 100, but radical 100 is just 10. And if we look at this, we've got minus radical 70, 10 times, yep, so minus radical 70 plus radical 70. Those are just going to cancel each other out. Minus radical 7 times radical 7 is radical 49. Radical 49 is 7. So the middles cancel out. So we've got 10 minus 7, which is just 3. And you're done. Now division. Remember, when you divide, you can't have radicals in the denominator. And now that we have polynomials, or no polynomials really, but we've got 3 plus radical 6 in the denominator, we have to multiply by what we call the conjugate. The conjugate is changing the symbol, so it's 3 minus radical 6. And now at this point, you need to make sure you FOIL this out. 4 times 3 is 12. 4 times radical 6 is negative 4 radical 6. Minus 3 radical 4. Nice. Plus radical 24. I'll simplify that in a minute. In the bottom, 3 times 3 is 9. Remember, the conjugate, those middle terms go away. So we've got minus radical 6 times radical 6, which is just 6. So on the top, the 12, if we just kind of look, this is 12. This is minus 3 radical 4. Well, radical 4 is 2. 3 times, so that's 12. So 12 minus 6 is 6. Can we break that down? That's 4 times 6. So this is 2 radical 6. 24 can be broken down to 2 radical 6. And I did that because I seen the radical 6 with the 4. So we've got negative 4 radical 6 plus 2 radical 6, so negative 2 radical 6. All of that over 3. All right, last one. 9x minus 2 to the 1/5. 5 minus equals 5 minus 8 to the 1/5. So they're both to the 1/5. So remember when we did these, we need to get rid of that radical, and the way we got rid of, or that exponent, the way we got rid of that exponent is we took each side to the power of the reciprocal. So we're going to take each of these to the 5th. As you go power to power, you multiply. So 1/5 times 5 is 1, so everything goes away, so you're just left with 9x minus 2 equals 5x minus 8. And then you go ahead and simplify that. Oops, I wrote that wrong. It should be 5 minus 8x. So that's 17x equals 7. So x is equal to 7/17. It's a nice 7. My gosh, so 7/17 is your solution for that one. And the last page, solving radicals. Step 1 is to isolate the radical. We did that. Next step is to because we're taking the square root, we got to get rid of that, so we're going to square both sides. So be careful when you square this because you got to square both parts. So 4 squared is 16. So that's 16x squared equals 30 plus 4x. So get everything on the same side. So that's 16x squared minus 4x plus 30 equals 0. Now we got 16x squared, so we got to factor out a like term. Common factor is 2, so factor out a 2. That leaves us with 8x squared minus 2x plus 15 equals 0. X method, remember we have to take a times c, so that's 120. And then negative 2, so that works out nice. So 12, negative 12 and 10. Now make sure we divide both sides by 8 and reduce the fraction. So that's negative 2/3, negative 3/2, I guess. So that's negative 3/2. So it's 2 times 2x minus 3. 10/8 reduces to 5/4. So 4x plus 5. Solve that for x, you get x is equal to 3/2. And then for this one, x is equal to negative 5/4. So we've got our two solutions. Now we need to check for an extraneous solution. So we have to plug 3/2 into our original equation. So 4 times 3/2, that has to equal the square root of 30 plus 4 times 3/2. So 4 times 3/2 is 6. That's equal to the square root of 30 plus 6, which is 36. So that works. Now we try the other one. And if you put in negative 5/4, you see if you put negative 5/4 in there, you're going to get negative 4 times negative. So it's going to be negative on the left-hand side, so we know that doesn't work. So our only solution to this is 3/2. That negative 5/4 is an extraneous solution. Okay. Last one. All right, it says what is the solution of the square root of 5x plus 5 minus the square root of x equals 3? So we've got two radicals. That means we got to split them. So that gives me radical 5x plus 5 is equal to 3 plus radical x. And it's step 1. Step 2, square both sides. So the left-hand side, we are just left with 5x plus 5 equals, well, so we've got, this is squared, so remember when it's squared, we have to take it times itself, so we have to take it times 3 times the square root of x, so that's 9 plus 3 radical x plus 3 radical x, so 6 radical x. X times x is x squared, square root of that is x, so plus x. Now I'm going to move the x and the 9 to the other side, and that's the only ones I'm going to move. I'm going to save some time. So that would give us 4x minus 4 equals 6 times the square root of x. And we're just going to leave it like that. I'm not going to divide by the 6 because that causes too many problems. Okay, I've still got that square over there, and a lot of times you do want to get rid of it, but in this case we've got that 6 sitting there, so it just causes too many issues. So at this point I'm going to square both sides. Okay, so 4x minus 4 squared, that's 4x squared. Okay, again, side note over here, 4x minus 4 times 4x minus 4. So that gives me minus 16x minus 16x, so that's minus 32x plus 16 equals 6 squared is 36. X, the square root of x squared is just x. Wow. Okay, so we keep going. We'll change to green now. So this leaves me with 4x squared, add 32x, add 30, subtract 36 from both sides, so that's negative 32 minus 36. Negative 68. X plus 16 equals 0. Common factor is 4, so factor out of 4. That leaves me with x squared minus 17x plus 4 equals 0. Does this factor? No. So we're going to call that good. Okay, we could use the quadratic formula to find the value of x. It doesn't have any real solutions. Well, b squared minus 4ac. Yeah, it does have real solutions, but we'll leave it at that. The one you have on your assessment, we'll make sure it comes out nice and pretty and nothing like that. So, yeah, there is this. Essentially what you're supposed to do today is work on this. So you could either do it the direction I did it, with me leading you through it, and then checking yourselves, or you could have done it yourself. So that was certainly up to you as to which way you wanted to do this one. So there's the review. We'll come back on Monday and work on section 5.5, and we'll have a quiz on Tuesday. Bye, everyone.